3.4, proving lines are parallel. Once again, we're going to review some very important theorems and a postulate from previous section. And it's so important, like I said before, that you understand what corresponding angles are. I'll let you review that part on your own. But basically, our theorems say corresponding angles are congruent, alternate exterior angles are congruent, alternate interior angles are congruent, and consecutive interior angles are supplementary. I'll give a quick example of one of each. Corresponding angles would be like angle 1, and alternate exterior angles will be angle 1. And alternate interior angles, we'll have to pick one on the inside, and angle something plus equals 180, supplementary, right? Let's go angle 3 again. Alright, so corresponding angle to angle 1 would be angle 5. They're congruent. The alternate exterior to angle 1 would be angle 8. Alternate interior to angle 3 would be angle 6. And the supplementary angle, the consecutive interior on the same side, would be angle 5. Okay. Now, if you remember, we talked about inverse, converse, and contrapositive. And in this case, the converse, when we flip the order of the theorem, the postulate and conclusion, it's basically true. So we have our new theorems for today, which are going to be the converse, where if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So last section, the lines had to be parallel, and we knew the angles were congruent. If we know the angles are congruent, then the lines are parallel. Likewise, alternate interior angle converse says if the alternate interior angles are congruent, then the lines are parallel. Alternate exterior angles converse says if your alternate exterior angles are congruent, the lines are parallel. And the consecutive interior angles converse says if your consecutive interior angles are supplementary, then the lines are parallel. Very important theorems, gotta know them. So the converse shows lines are parallel. In this example, solve for x in order to make the lines parallel. If these lines are parallel, what has to be true about these two angles? So you first have to look at these two angles and say, these angles are what type? Alternate interior, alternate exterior, corresponding, or consecutive interior. And they are consecutive interior. And then we got to figure out what that means. And if you look, this angle's acute, this angle's obtuse. Hopefully you realize that then they have to add up to 180 if the lines are parallel, and that's what we're looking for. So x plus 4x is a 5x. And when I divide by 5 goes into 18 3 times. You're left with 20. 5 goes into 20 4 times. So x is 34. Yesterday we did a proof of alternate interior angles theorem. Here we're going to do the alternate interior angles converse. The converse of that theorem. We'll do a flow proof. So we're given that angle 1 and angle 2 are congruent. We want to show M is parallel. That's the symbol for parallel to N. So let's start with our given. And I already have the things in line, so I get to move them around. I'm given that I want to prove M is parallel to N, so I'll move that down out of the way. So if I know angle 1 and 3, or excuse me, I'm not given that one. I didn't read the problem close enough. I know angle 1 and angle 2 are congruent. What can I conclude from that? I know they're equal, but does that help me? If I want to show M and N, I'm going to go back to that corresponding angles converse. That's basically a postulate that we're starting from. So we can always use the postulates So I'm going to use I know why angle 2 and angle 3 are congruent. Grab the wrong one. Angle 2 and angle 3 are vertical angles. Angle 1 is congruent to angle 3. I can then conclude, and I know why, by the transitive property. So I lined them up so I can draw these arrows in. So I'm using both these statements, right? I'm using angle 1 is congruent to 2, angle 2 is congruent to angle 3, therefore 1 is congruent to 3. We're skipping over 2 with the transitive property, and now we can conclude that, oops, I had to grab an arrow. Now we can conclude that has to be the case by the corresponding angles converse, okay? So we didn't use this theorem. We used stuff that we've already proved, and basically that we are accepting as a statement. It's kind of a postulate. And here's, I think, our last example. We want to talk about which lines are parallel, and I often just get people that say, oh, this must be parallel to this, and this must be parallel to that. You can't assume, okay? So you can't just assume that. I'm not sure. So let's actually find out. We have to look at what? Our corresponding angles have to be congruent, right? So if this angle is 155 and this angle is 115, they are not congruent. AD and BC are not parallel. Where here, this, I'll use a different color here. That angle is 65, this angle is 65. I look at that and I say those are alternate interior angles. And they are congruent. So alternate interior angles are congruent. So by the alternate interior angles converse, I would say, so which one? These are my inside. They're inside the parallel lines, right? So my parallel lines are going to be BC is parallel, two big parallel lines to AB. Okay, those AD and BC are not parallel. Remember, pictures aren't necessarily drawn to scale. There's your homework assignment. Have a good night.